Hello and welcome to Pep Talk with me, Mr. Pepperell. Today I'm wondering, why aren't we making all our electricity using fusion? By the end of this episode, you should be able to understand just why is it so hard to make a nuclear fusion reactor.
In the last episode, we found out that stars, like our sun, are so hot and shiny due to the process of nuclear fusion that is going on inside of them. And in this process, small nuclei fuse together to produce large nuclei, and in the process, we found out they release a lot of energy along the way. Okay, so why is all of this going on only inside stars and not here on Earth all the time? Well, there are actually big difficulties in turning this process into a useful source of energy. And the main issue is that the plasma, if you remember the plasma inside the sun, the plasma of the light small nuclei has to be heated up to super high temperatures in order for the nuclei to fuse. Well, why is that? It's because of something called electrostatic repulsion. You know that the nuclei are positively charged because of the protons. They're both positively charged, and we know that like charges will repel each other. Okay, the positively charged nuclei just want to push each other apart. So they need to be heated up an awful lot before they can gain enough kinetic energy to overcome this electrostatic repulsion and actually bump into each other. But it is possible to do this, okay? This is actually the inside of a nuclear fusion reactor. And you see the little bloke just climbing up there to give it a bit of scale, okay? And in here, what we do is we heat up that plasma of deuterium nuclei, okay, to sufficiently high temperatures by passing an electric current through it, okay? So if I just turn my reactor on there, you can see that what I've actually got here is that super hot plasma which is being generated inside the nuclear fusion reactor. Okay, now if this superheated plasma was to touch these outside walls of the reactor, it would start to cool down and the fusion would stop. So what we have to do is we have to contain this plasma inside magnetic fields, and basically around the outside of here what you've got are ginormous magnets which are containing the super hot plasma inside a magnetic field here. Now, as you might guess, this process actually takes an awful lot of energy input to get it going, and at present we can't sustain the process for long. But if we could, it would basically solve all of our energy problems forever. So how is it going to solve all these problems? Well, firstly, because of the fuel. Because basically the fuel is just pretty much all over the world, just sloshing about. Okay, as you'll remember, all the light deuterium that we need to use as fuel in this nuclear reaction can be found in seawater. Okay, so you know, it's a free fuel, so that is a big bonus for us. Okay, and when you compare that with the hard to find uranium that we use in nuclear fission in current nuclear power stations, that is a big bonus. Okay, secondly, what is the product of this reaction? Well, the product of the reaction is helium. Okay, that is what you get at the end of all of this, which is not only a radioactive harmless gas, it's actually pretty useful, you know, so that's a big tick. We can use that you know, to as a coolant, and we can use it to fill up party balloons, which is always nice. Compare that product to the product of nuclear fission reactions, which is nuclear waste which stays radioactive for thousands of years and is a lot of hassle to store. Okay, and finally, all the energy being released could easily be used to generate massive amounts of electricity, which is basically what we need. Okay, so fusion, nuclear fusion, is going to be a big bonus, and what scientists are currently working on is something called cold fusion. The breakthrough would be to crack the problem of cold fusion, and this is getting those nuclei to fuse without the high temperatures. So cold fusion is currently a problem just waiting for a solution, and maybe, just maybe, it'll be you that solves that.
So that's everything we need to know about nuclear fusion reactors and why we haven't quite got them working properly yet. Any problems with that at all, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.